Hello, good afternoon. My name is Brian Robbins. I am with Coinbase, and I'm here to talk to you today about powering progress via partners. Basically, what kind of technology we use in our staking platform, and how the different ways that we look at the underlying technology, the types of blockchain technology that we use, and overall the way that we think about things and look at the different technology options that are out there and how that leads to the types of decisions that we decide to make with them. So first, I'll start off with a little bit of background. I lead the engineering team for our Coinbase Cloud Staking. This is all of the validators that we run for our internal customers, our prime clients, retail, as well as a number of our external customers. My teams operate validators and all of the tools and tech that support this operation. So we run validators across over 15 protocols that represents over $15 billion in assets that are staked. And we've been doing this since 2019. We started running Ethereum in 2020. We've one of the longer staking operations that's out there. It's really about doing this at scale and doing this really well. And, for further background, Coinbase, we're known as the most trusted name in crypto. This comes from one of the most important things that we do. It's always about trusting and making sure that our customers can trust us. It's having the security and reliability, making sure that that always comes first. And the number one thing that we can do is make sure that we protect the assets and protect the networks that we operate. That's something we take very seriously, and that's always our first job. Job zero is making sure that we take care of customer assets, and that's how we protect ourselves as being the number one trusted name in crypto. After we get past that, we start talking about scale. I mentioned the 15 different networks that we operate, the large number of assets staked, and it means that we need to do everything and think about the scale of operations that we bring to the table. It's really about bringing efficiency, the highest levels of performance across all the networks that we operate, and trying to do that with as minimal human effort as we possibly can. We need to not just throw people at the problem, we need to be able to do this reliably and with scale. So looking at how do we eliminate the manual operations that are out there, the one-off processes, it's all about repeatability. If we have to do something once, that's fine, but if we have to do it more than once, we're gonna write scripts to do that. We're gonna create tools to automate those processes. And overall, we think about this as humans exist to introduce errors, so we try to minimize the opportunities that humans have to introduce those errors into the systems and the things that we do. We consolidate our tooling as much as we can, try to consolidate our configurations, and it's really about trying to use the same tools across all of the different networks that we operate. Because ultimately, if we can get to a place where many of the operational issues that our teams face don't require deep network experience, that lets us scale. It lets us scale the people, it lets us scale the tools, it lets us scale our operations a whole lot better. And ultimately, that's where we are at, is that many of the operations issues we have today don't require that deep network expertise because we've done a good job building out some of these tools and trying to eliminate snowflakes or places where we have a unique setup for one protocol or one validator, trying to minimize and prevent that from happening as much as we possibly can. And all of these are the ways that we bring to the table so that we can operate at the scale that we need to. So bringing that to the underlying technology and some of the choices that we've made here, first off, we're multi-cloud, multi-region. Again, large number of assets, large number of protocols. We primarily host through AWS, GCP, and we also further decentralize through multiple regions. We have regions across Asia Pacific, North America, and Europe. So again, making sure that we're decentralized across the full footprint that we can within both AWS and GCP. And it's all about ensuring that there's no single place where a failure can take down everything. We have to accept the fact that there are places where an AWS region may go down, a GCP may have networking issues. We need to ensure that regardless of what happens there, our networks and our protocols and the validators we run are resilient to those kinds of errors. And this helps us build and scale quicker. Building on top of AWS and GCP, especially really early on, back in 2019, 2020, as we were getting this started, let us not focus on how do we set up and maintain these machines, but how do we just sit on top of AWS and GCP, not have to worry about that underlying hardware. This was a really big part of our early growth, and now we feel like it really helps us scale and make sure that we have a nice, mature, scalable platform to build everything on. But it's challenging. If you've ever tried to build things on AWS and GCP, there's a lot of differences there. They're not exactly the same. And so this is where we bring in Kubernetes and Terraform. And so using EKS, GKE, this lets us build everything on top of the cloud providers and lets us normalize away a lot of those differences and the changes that are between it. We also very much bring to the table infrastructure as code, build in our infra, our metrics, alerts, dashboards. Everything gets configured. Everything gets set up through code so that we can easily recreate things. We can manage the change. We don't, again, have snowflakes. We don't have one-off processes. We don't have a lot of manual errors that can get put into the system. Again, all of this bringing back to how do we scale better and how do we bring this stuff together. And it's about abstracting away these differences and making all of the different protocols, all of the different places we host look as similar as possible to each other. And then sitting on top of that, coming up the stack again, one step above it, is our CI/CD platform. So we use Concourse CI. This manages all of the builds and tests and all of that kind of process. We also built something out that we call protocol pipelines, and this is a set of internal framework that sits on top of Concourse. It's very specialized for protocol deployments. It helps us set up the test suites. It helps us set up the staging environments, the test nets, the main nets, build out all of our deploy groups, all of this stuff kind of sitting on top of Concourse CI. Again, bringing it back to how do we do this at scale across all of the different protocols that we work and operate. And then we have a bunch of other internal build tools that we've built out over the years, mostly, again, looking at what are things that we have to do more than once, and anything we have to do more than once, we look at how do we build a script, how do we build a tool around this, how do we make it repeatable so that it can either do it automatically or do it at the push of a button without needing a human to kind of go in and manually set the right parameters and configurations every time they need to go do something that we're going to do regularly, day over day, week over week. So coming up the stack one more step, I want to talk about one of the pieces of technology we introduced in the last couple of years that has really been one of the largest unlocks for our team and the scalability. We call it Protocol CDK. And this follows the AWS Cloud Developer Kit model, or the AWS CDK model. And what it did was it brought a single language, TypeScript in our case, and through that interface, we now configure every protocol that we work with. Prior to this, if you were setting up a protocol, you might be dealing with 4, 5, 6 different languages, depending on the protocol, depending on where you needed to go. You had various configuration files, a bunch of different technology places. And once we introduced Protocol CDK, we got that down to one single place, generally one single script. So anytime you're changing something with any of the protocols that we operate, you can do that in one place. It makes us build faster. It helps us actually onboard protocols when we're launching new chains and new networks. We do this 3 to 4 times faster than we did before. But more importantly, we do that with even higher confidence. We're able to bring in the same set of testing suites. We're able to bring in the same set of alerts and metrics and alarms. All of that stuff comes in for free because we have it built within CDK. And just by virtue of using this tool set, we've simplified that work. We've abstracted away a lot of that work. So we move faster and more reliably at the same time. And this has been, again, a massive unlock for our teams over the last couple of years and really has helped us scale and get to where we are today. So that's some of the kind of generic technology that sits underneath our stack. Next, I want to talk a little bit about some of the blockchain technology and some of the things that we're excited about, some of the things we're looking at, some of the things that we've introduced over the past few years. So first up is MEV. And we started with Flashbots. We introduced this in 2022. We've since then introduced a lot of multiple other relays. We had Jito for Solana. And the goal here is really we wanted to increase the yield for our customers. But we also, being very crypto native, we want to make sure that we maintain proper proposer-builder separation. And this is, again, one of the things we're trying to pay attention to is when we're looking at technology, what does it do for our customers? In this case, MEV helps increase the yield that we have for customers. But we want to do this in a way that sticks to the ethos of crypto and make sure that we stay credibly neutral. We want to keep everything very aligned with the mission and the ideas behind the folks that are trusting us to help operate these networks. And ultimately, we've seen a lot of success with MEV. It has increased yield, it has brought better returns to our customers, and we're able to implement this and do this at scale. Something that we're paying a lot of attention to now and looking at, as I'm sure many of you are as well, is restaking. So looking at Eigenlayer, obviously, there's a number of other players in this space too. And the idea of restaking, if you're not familiar with it, is you can take the ETH that you've already staked on a validator like Coinbase, and you can then go restake it and basically commit and use that asset to help secure an additional use case. And those additional use cases could be things like a data availability layer, oracles, other networks, which is kind of similar to the way Cosmos Hub works and the consumer chains they have there. But this is a place where it also introduces a huge amount of complexity. There's a ton of unknown risk. You're allowing the eigenlayers or the restakers to have the ability to slash your tokens again as a result, as part of the trade-off of using it to help secure their network or secure their additional tokens or tools that they want to introduce. And so this is a place where we have to be very careful and pay attention to the balance of innovation, security, and reliability. Security is always up front, and security is always first and foremost for us, but we have to pay attention to innovation. And ultimately, we would like to increase yield for customers. And we see restaking as a great way where there will be lots of opportunities to go ahead and increase that yield, but we've got to make sure that we're doing it in a way that makes sense and doesn't introduce too much risk into the products and the tools that we're offering. And as we're looking ahead a little bit further, DVT, this is something we were talking a lot about last year here at ETHDenver, something we're still very excited about. There's tools from multiple providers. Obol, SSV are two of the ones we've paid a lot of attention to. Super interesting potential here. The idea behind DVT is that we can, instead of having a single validator run an ETH node, we can distribute that across multiple validators, maybe a set of where we need 3 out of 5 to run or 4 out of 7 to run and be online. And that gives an operation like ours the ability to scale even further. It lets us do the kind of maintenance and upgrades and security patches that we need to be doing, and we can do that without ever having to take a validator offline. One of the most important things to us, again, security, means that we have to stay on top of security patches. We have to stay on top of everything that we need to do to trust and keep everything reliable. And tools like Obol, SSV, and the DVT that comes in may let us do that and may let us increase that security posture and do it in a way that lets us scale reliably. But it also introduces a very complicated extra layer into our platform. And this is why we're still paying attention to it. It's still something we're looking at because that complexity piece hasn't been worth it for us yet, but it's something that I'm still very excited about looking ahead. And that kind of brings us to the way that we make decisions and what are the key things that we're going to pay attention to. I've talked a little bit about some of these as we've been going today, but it really comes down to 3 major components. And the first is trust. Security and reliability is always the number one, first and foremost thing that we can do. That's the number one thing we have to pay attention to. When we're looking at something like Obol and SSV for DVT, some of this comes back to the teams and the underlying teams that are building it. As we're looking at restaking and Eigenlayer, not just the Eigenlayer team, but which AVS operators are we going to potentially introduce? Which projects are we going to allow our customers to support? And we need to understand we do have a role here with our limited bandwidth that we can't just adopt everything. And so one of the first big places that we're going to pay attention to is who's the team behind it? What does their code look like? How are their development practices? And is this something that we can trust? Where it comes to smart contracts, have those smart contracts been audited? Are we able to look at the code? Are we able to give our own stamp of approval onto the things that we operate and bring into the platform? Because again, security has to come first, and there's nothing that we're going to put before trusting and taking care of those customer assets. The second piece we pay a lot of attention to is the operational impact of what we're introducing. Again, large scale. lots of protocols. We're very careful to introduce snowflakes and prevent that from coming into our systems. And that means we need to pay attention to the operational impact. There's some of the protocols that we've operated and have actually decided to stop operating over the last couple of years, primarily because they were so difficult to run. They were so hands-on. They did have so many challenges and so much impact on our teams and on our ability to run them effectively that the trade-offs didn't make sense anymore. So we're going to pay a lot of attention to that operational impact. Part of my job, a big part of my job, is to protect our team, protect our operations, and this again comes back to protecting our customer assets. If a team is up all night, every night, dealing with issues because something that we've deployed is unstable, that makes them less likely, less able to respond to things during the day. And we've got to make sure that we keep our team fresh. We've got to make sure that we keep our team operating at the highest level possible. So we're very sensitive to anything that'll reduce the operational impact or operational effectiveness of what we do. And the third thing is customer impact. After we've taken care of security, after we've taken care of the operational impact, what is it doing for the customers that want to use our services? Is it increasing rewards? Is it bringing more optionality for customers? We are here to serve our customers, and our goal is to make sure that we're taking care of the networks, the primary networks that we're doing, and that's really on behalf of the stake that our customers are putting their trust in us to represent. And so we need to make sure that we're delivering the things that our customers are looking for, that we're offering the opportunities that they want to see, and that we're giving them the chance to be able to allocate their assets to help protect the networks and tools that they're most interested in and excited about. So that's really what it comes back to at the end of the day when we're looking at what are we going to support. It's what do our customers want? What's the operational impact, and can we trust it? Can we trust the team? Can we trust the technology and everything else around it? And that really kind of wraps up a very quick highlight of how we look at things at Coinbase and the way that we approach our staking business and our validator infrastructure. I really appreciate your time today, and I'll be over here on the side for a few more minutes. If anybody has any questions, I'd be happy to talk to you. Thank you.